Excuse me. Okay, 5.2. We are going to continue with functions. So the first question deals with what are called piecewise functions. And they're a little bit weird. So in a regular function, you take a number, you plug it into the equation, and it spits out an answer. But piecewise functions contain more than one function. They could contain 2 or 3 or as many as you want. So this one contains 2. And here are the instructions on how you plug things in. If the number you're plugging in is equal to 2, then that is your answer. If the number you're plugging in is not equal to 2, then you stick it in there. So the first one says plug in -1. Am I going to use the top equation or the bottom equation? The top one. Now, you have to be careful when you square negatives. Anytime you plug in a negative or a fraction into a function, you always use parentheses. So I put -1 right there. What is -1 squared? 1. And then times that by 1/3 is 1/3. How do I subtract 5? Make it into a fraction, 5 over 1. I need a common denominator, 3, so 3 over 3. And I get 1 minus 15 over 3, which is -14 over 3. Okay. How do you plug in 2? Which equation do you use? The bottom one. Where do you plug it in? You don't. The answer is 3. That's the retake. So you don't have to do it. Okay. And then 4, I would plug 4 in there. Now, let's do a different one. Let's look at number 6. Okay. This function has 3 pieces. So if I want to plug in -3, which piece do I plug it into? Does -3 fit here? Is -3 smaller, less than or equal to -2? Yes. So we plug -3 in here. So -1/4 times -3 minus 2. How do you multiply fractions? Put it over 1 and multiply. -1 times -3 is 3. 4 times 1 is 4. Did you step on a mouse? So 2 over 1. I need a common denominator. So on top we have 3 minus 8, and on bottom we have a 4. 3 minus 8 is -5. So -5 over 4. Okay. Next one. Which one does 0 fit in? Is 0 smaller than -2? No. Is 0 bigger than 1? No. Is 0 bigger than -2 but smaller than 1? Yes. So I plug 0 into this equation. 0 plus 1 squared plus 2. 0 plus 1 is 1. 1 squared is 1. -1 plus 2 is 1. Okay? And then where do I plug in 1? Does 1 fit here? No. 1 is not bigger than 1. Let me zoom in a little bit. Okay. Is 1 bigger than -2 but smaller than 1? Yes. So we would put 1 in here and solve. Does that make sense? So look at your x value, or what, and then figure out which equation you plug it into, plug it in, and then simplify. Okay. Michael earns $44 per week working part-time at a bookstore. He makes $1 more for each book that he sells. The amount in dollars that Michael earns in a week if he sells B books is given by the following function. So this is how much money he makes every week going to work. But every time he sells a book, he makes $1. So if he sells 35 books, how much money will he make? You're just going to plug 35 in there. 44 plus 35. Hi. Okay. So let's do number 3. Kind of a similar problem. It will. Yeah, it will. Okay. A plant is already 10.75 meters tall and it will grow 9 centimeters every month. So there's the equation. All you're doing here is taking 20 and plugging it in for x. Okay. Number 4. John wants to save $800 to buy a TV. He saves $18 per week. So this equation represents how much more he needs to save. Okay, so we need to be careful here. So in this case, this is weeks, and this is the amount left. So the W is how many weeks he's saved, and A of W, it's like the Y value, that is how much he has left. So after 0 weeks, he still owes $800. But after 1 week, we plug 1 in here, and then 800 minus 18 would be 782. That's how much he has left to go. Okay? So if John still needs $494, how many weeks has he been saving? What do we do with that? Where do we plug that in? We plug it in for A of W. So 494 equals 800 minus 18W. How do we solve that? Add 18W and subtract 494. So 18W equals 306. Now we divide. Turner, what do we get? 306 over 18. 306 divide 18. Equals 17. Okay, where did you get confused? So we have 2 parts. This is weeks, and this is amount left. So it told us he has this much left. So we need to plug it into there. And that gives us this equation. And then we just solve. We move this over here by addition. We move this over here using subtraction. We get 18W equals 306. Divide 18. You could do that. Yeah, it doesn't matter. Well, I don't like negative variables, but it would totally work. If you moved them the other way, then you'd get 2 negatives when you divide, and it would be the same thing. Okay. Letter B. How much does John still need after 6 weeks? What do we do there? Plug 6 in for W, and we get 800. Wow. 800 minus 18 times 6. What is that, Turner? $692. So after 6 weeks, he still needs to save $692. All right, I believe this is the last one. A construction crew is lengthening a road. Let L be the total length of the road. Let D be the number of days the crew has worked. Suppose that function gives L as a function of D. The crew can work for at most 60 days. So we're building a road from this city to this city. Okay? And this equation so hold on a second, let me read that again so we don't. Let D be the number of days the crew has worked. All right. So every day they work a little bit more and they get more road done. Okay? So L is the length of the road that they have completed, and D is the number of days they have worked. Yeah. And what does this tell you? The crew can work at most 60 days. So yep. All right. So the domain. The domain are the numbers we get to plug in. Do we get to plug in the length of the road or the number of days? We get to plug in days, and what would be the set of days? Could it be all real numbers from 4 to 300, all numbers from 0 to 60, or 60, 61, 62? Which one? This one. Okay. And the range would be the length of the road. How long can the road be? Well, let's look. Our equation is L equals 4D plus 300. So what's the smallest number we're allowed to plug in? How many days can we plug in? Up to 60, but we can go all the way down to 0. So let's plug in 0. And I get 300. Okay? What happens when I plug in 60? What is 4 times 60? 240 plus 300. So apparently, the road is already 300 miles long. And after they're done working, the road will be 540 miles long. Is that an option? This one. Okay? So how do we get the domain? We look at the numbers we're allowed to plug in. How do we get the range? We plug in the smallest domain, and we plug in the largest domain. And that will tell us the range. Right. Get to work.